Today we are going. We in the previous lecture we have covered the modeling of the distributed parametric system, right? And we have taken one example of the heat conduction in a solid, right? So today we will see the development of model for the different types of the couple system, couple tank system, right? So before that, we have two example. You can say for the state space technique. Now, as you know, we have already covered this part in the modern control system also. So we have to develop the model or represent this type of the model into the state space representation, right? So this is a mass damper spring problem. You know how you write the equation. This is a simple disturbance, and based on that disturbance, the displacement will got, okay. And based on that displacement, we have to write the equation. Okay, F is equals to ma, right? So d2x by dt square, you know very well, dy by dt square plus anyone can tell me, m into d2 by dt square, b into dy by dt, and plus k into y, right? And let's say we have the disturbance or the input as a u, okay, force. Then we have to equate this equation, right? So this equation is written in the form of this y dot, y double dot, okay, plus f by m. Here b is represented in the form of f, right? And k is the spring constant or the Hooke's constant, and we have taken the equation, right? So define the state variable x1 t is equals to yt and x2 t is equals to y dot t. So based on this, you can define the equation, right? Equation, and then the initial condition just to provide and write down the, based on this equation, you can write the state space equation in the form of this. Is it okay? Am I right? Have any problem? I think no. Okay.
Yes.
Okay. So this is the the state space equation. The any in general, you can say a physical system described by the state variable as follows. You can say the x1 dot is equals to this. This is the input side. Sorry, this is the state side, x1 to xn, and this one the input side, right? This is the state and input. So here n x, the number of x variable is n, and the input variable is m. So we have written like this equation. So general equation you can write x dot is equals to fx. You know very well because we have already covered these things into the now in the modern control system, right? So we can write the equation in the form of this x1 dot in the matrix form. This is the A matrix, This is the B matrix, So y is x dot is equals to ax plus bu, y is equals to cx. Okay. So these are the some representation of the dynamical system, right? Dynamical system. Now we are going to start with a very important and very interesting topic, that is the coupled tank system, right? Coupled tank system. You can see there are two pictures shown here in the figure A and figure B, and there are the much difference. There are slight difference in the arrangement of the two tank. You can see here in the first tank, whatever the output is coming from the first tank is directly coming to the second tank, and this is into the without any connection. You can say this is without any connection. This water is going, or this product is going to enter into the tank 2 without any connection, or you can say the in the contact of the air, in the contact of this air, right? However, in this arrangement, you can say there is one pipe connected in between the tank 1 and tank 2, tank 1 and tank 2, right? And from this connection, from this pipe, whatever the resistance R1 is here connected, or the resistance or the valve is here, you know the water, whatever the product is coming from the tank 1 is going to into the tank 2 here also, but it is not in the direct contact of the air, it is in the contact of the pipe. है ना, पाइप यहाँ पे कनेक्टेड है, और पाइप के थ्रू वाट एवर द प्रोडक्ट इज एंटरिंग इनसाइड द टैंक टू. सो इस दोनों के डायनेमिक्स, whatever the dynamics we are going to develop for these two will vary, right. अभी हम लोग देखेंगे डायनेमिक्स केवल इस कनेक्शन के चलते. क्यों? क्योंकि ये R1, this due to the connection between the two tank, the R1 now will dependent on both the tank 1 as well as tank 2. Am I right or wrong? Am I right or wrong? However, in this scenario, this R1 is only dependent on this tank. Yes or no? This R1 is only dependent on this tank. However, in this scenario, the R1 is dependent on both the tank. You have already seen what is the formula for the, Q, R. What is the relation between this Q naught is equals to H by R. Okay. So from this, you can say here, what is the R1 here? What is R1? But please, Q1 is equals to
H1 by R1.
H1 by R1. However, in this case, Q1 is equals to
H1 plus H2 by R1.
H1 minus whatever difference. This is coming from this side to
Minus.
this side. Now the
Yes.
difference. H1 minus H2 by R1. So this is the major difference in between the connection between the two, and therefore this type of the system is known as the interacting tank system. Interacting tank system, and it may be the non-interacting system. Non-interacting tank system. Now, in your exam, there are 3 to 4 tank system may be given like this. So this is this is the interacting, this is the non-interacting. Now we have to develop the model. Okay. So any arrangement type of the system may be given, right? So आप लोग को model develop करना है. So major fundamental you have to understood. The whatever the fundamental is, the difference only in the resistance. Okay. Now come to the modeling part. First, I want to cover the non-interacting system. So in the non-interacting system, I have described what the non-interacting system. Let's say the area of this tank is A1, and the level of this tank we are going to control is H1, and here is H2. Area is A2. Flow rate of whatever the entering in the tank 2 is Q1, or you can say the product flow rate of the tank 1 is the Q1. Okay. So based on this specification, try to develop the model. As you know that for the single tank system, what can be written? Please tell me. Can we write Q minus Q1 is equals to AdH1 by dt? Yes or no? This minus this is equals to AdH by dt. बाकी सारा cancel हो जाएगा. Yes or no?
Yes.
You can see here.
Yes.
You can see here the equation. You can see here. Q naught is equals to AdH by dt. Density will cancel out. Yes or no? So based on this, simply I have written the equation Q minus Q1 is equals to A1 dH1 by dt for the tank 1. And what we write for the tank 2? Please tell me.
Q1 minus
Q1
Q2
minus Q2 is equals to A2 dH by dt. This is for the second tank. Okay. Now, what will be the Q1? What will be the R1? How to define the R1 and R2? Defining the R1 and R2, so you can write Q1 is equals to H1 by R1, Q2 is equals to H2 by R2. Is it okay?
Yes, sir.
Q1 is equals to H1 by R1, Q2 is equals to H2 by R2. Okay? Just put the value, है ना? और उसके बाद आप क्या करेंगे? डेविएशन वेरिएबल स्टेडी स्टेट में लेके माइनस करके, when you solve the equation, you got it. As you know that Q1 upon QS, when you put the value, right? H1 is equals to Q1 into R1, है ना? When you solve this equation, you will got that the q1 upon qs will come. q1s matlab this dependent up this divided by this for only the single tank, not for the double tank. Single tank, q1s upon qs will come 1 upon tau s plus 1, where tau 1 is already defined a1 r1, or this is the deviation variable q1 minus q1. You already have done these things. Okay, now what is your ultimate target? Your ultimate target is to control this level, yes or no? Ultimate target is to control this level. From this, the input is, now we are going to take the q, this input, main input. So you have to find h2 upon q, h2 upon q. Okay, h2 upon q try to find. तो h2 upon q के लिए हम अगर हम ऐसा करें h2s upon qs, so now let's say h2s upon q1s and q1s upon qs, if we'll define like this function. So as you know that q1s upon qs we have defined here, q1s upon qs we defined here, right? So q1s upon qs is this one. Now I'm going to define h2s upon q1s. h2s upon qn means h2s upon this q1s. You can define h2s upon qs just to solve the equation. Simple. Just to solve the equation h2s upon qs, we will got this r2 upon tau 2s plus 1, right? Put this value here. Now you can solve, and you got that 1 r2 upon tau 1s plus 1 tau 2s plus 1. Try to solve this equation. If you not solve, then we not got like this, है ना? अगर आप practice कीजिए, try to practice the equation. I have already written from the book, है ना? Book में पूरा description दिया हुआ है. Try to solve from your side, है ना? Okay, right? So h2s upon qs will come like this: h2 1 upon tau 1s r2 upon tau 2s. This is a second order system, yes or no? Second order system. Order system. And what is tau 1? Tau 1 is equals to simply a1 r1. And what is tau 2? Tau 2 is equals to a2 r2. Okay, or you can see this is second order system. तो डबल टैंक होगा तो इन एनी कॉस्ट इट विल गिव द सेकेंड ऑर्डर. सेकेंड ऑर्डर. सिंगल टैंक था तो क्या दिया था बेटा? फर्स्ट ऑर्डर. It means you have the number of, let's say we have the number of connection, then that will give the n number of nth order of the you can say the order. Okay, now let's say now we are going to simulate the system, okay, in the MATLAB. So let's say this, anyone who are not aware from the MATLAB simulating model, this is the first time he is or she is seeing. ऐसा कोई है? Everyone is aware? Okay, so let's say we have this tank. Now there are two possibility. First possibility is the second tank I am only taking, where H2 and Q2 R2 is the case, और Q1 यहाँ से इस तरह से कुछ फ्लो हो रहा है. एक केस ये है, दूसरा केस ये, डबल टैंक और सिंगल टैंक. नाउ वी वांट टू कंपेयर द रिस्पॉन्स. ओके, फीड इज गिवन. तो आप यहाँ पे देखें, लेट से टाउ 1 इज डिफाइंड एज अ 0.5, टाउ 2 इज ऑल्सो डिफाइंड एज अ लेट से 1. ओके, सो यहाँ पर हमने डिफाइन कर दिया फंक्शन 1 अपॉन 0.5s प्लस 1, 1 अपॉन 0.5s प्लस 1, एंड दिस इज द 1 अपॉन 1 प्लस s, राइट? और हमने कोई स्टेप रिस्पॉन्स दे दिया लेट से फीड. और यहाँ पर सिंगल टैंक इन द सेकंड केस देयर इज ऑलवेज द सिंगल टैंक, देयर इज द 1 अपॉन s प्लस 1, 1 अपॉन s प्लस 1, राइट? r2 इज वी हैव टेकन 1, तो 1 अपॉन s प्लस 1 यहाँ हो गया. दोनों का हम रिस्पॉन्स कंपेयर किए. यू कैन सी हियर the second the interacting system or the two tank system response is like this one. It is slower, you can say. However, the single tank response is faster than this. Okay, you can compare these things. You can also simulate the same system or the different type of the system on the MATLAB. Any doubt? Yes or no? Am I audible?
Yes, sir.
Yeah.
Go on.
Okay. So if you are taking the n number of the tank. If you are taking the n number of tank, you can say that the response will become slower and slower. So this is for the single tank, this is for the double tank, this is for the triple tank, and so on. When your tank, the number of tank is increases, right, your response will go slower. It is like this. You can see. You can simulate the system on the MATLAB. See. Okay. Now come to the next. This is the interacting type of the system now we are going to discuss. In the interacting type of system, we already have discussed this Q1 is nothing but the, can anyone tell me what it will be the, this H1 minus H2 by R1, because this is the interconnected. Okay. So just write the equation Q minus Q1 is equals to, for the tank 1. For the tank 1, Q minus Q1 is equals to A1 dH1 by dt, right? And for the second tank, Q1 minus Q, right? Q1 minus Q2, yes, this is Q2. Okay, Q1 minus Q2 equal to A2 dH2 by dt2, right? This is the equation. And you know, the Q1 is equals to 1 by R1 H1 minus H2. We already have defined. What is the Q2? What is Q2? Q2 will simply, yes please, Q2 is equals to H2 by R2.
H2 by R2.
Is it right? Based on this 4 equation 1, 2, 3, 4, your target is to find S2S upon QS. S2S upon QS. Define the deviation variable, define the, S2S upon Q1S, Q1S upon QS, all these things, and you will find in final stage the transfer function will come like this. So there's the difference. Remember, in the first type of the system, or you can say the non-interacting system, you will find the transfer function 1 upon tau 1s plus 1 into R1, I think, R2, R2 upon tau 2s upon 1, right? Tau 2s upon 1. So you can see this is the multiplication of, the 1 upon tau 1s plus 1, 1 upon tau 2s plus 1, and the resistance of the last. However, in this case, both are the second order system. It is also the second order system, it is also the second order system. But the characteristic, but the nature, but the equation of both the equation are different. Tau 1 into tau 2 s square plus tau 1 plus tau 2 plus A1 R2 into S plus 1. This is the characteristic of the interacting system. So what will be the effect on the response? You can see here. You can see here in this when the non-interacting system and when the interacting system are simulated, both are simulated. You can see here with the both having the same time constant. You can say here the curve, the nature of the response of the non-interacting system is faster than the non-interacting system, right? The response of the non-interacting system is faster than the interactive system. So this is the interesting result, right? So you can conclude here from this figure. It can be seen that the interaction system slows up the response. This result can be understood on the physical grounds in the following way. If the same size step change is introduced into two systems of the figure, the flow tank, you can say, for the non-interacting case will not be reduced by the. So these are the case, right? Now your task is to find out the transfer function for this system. Okay, try to solve such type of problem, because this type of the problem may be asked in your exam, right? This type of the problem may be asked from the exam. Okay, so now what is this? This is a constant pump, right? Constant pump means uh there is a no valve here. Always it gives a constant flow rate. Okay, this pump will provide you a constant flow rate, right? So what will be the dynamics of the system? If you know, then you are able to find out the model of the system. So it is the last discussion of today. Liquid level process with a constant flow outlet. So you know qt minus q naught is equals to a whatever the area dh by dt. Am I right? Yes or no? At the steady state, the qs minus q naught is equals to 0. Qs minus q naught is equals to 0. Right? So just to take the deviation variable q minus qs, or it is, at the steady state it remain again the same because it is the constant value q naught and q naught. Yes or no? In the
Yes.
initial
Yes,
condition,
sir.
qt minus q naught is equals to a dh by dt. However, in the steady state, again it will the constant q. It will go on the on the steady state value qs. However, this will remain constant because it is a constant value. So q naught, okay, and therefore I am writing like this. We have taken the deviation variable q minus qs, q naught cancel. So it will give simply q is equals to a dh by dt. Am I right? Yes or no? Tell me.
Yes, sir.
So q is equals to a dh by dt. When you take the Laplace transform, what will give? Simply qs. It is a s hs. Take the Laplace transform. Hs upon qs is equals to 1 by s. 1 by a into 1 by s. What is a? A is the area. A is the area of the tank. What is 1 by s? What is 1 by s? 1 by s
Integrated.
represents integrator.
Integration.
To st,
Integration.
you can write simply st is equals to hs, the steady state value, plus 1 by a, 0 to t qt dt. Is it clear? Yes or no? So clearly, if we increase the inlet flow to tank the level, what will the interpretation of this equation? Integration का क्या मतलब है? The level will increase because the outlet flow remain constant. It is remain constant. Yes or no? So what will happen? It will happen क्या होगा यहाँ पे कि the level will increase, है ना? The excess volumetric flow rate into the tank accumulates and the level rises. Simple. Okay. Now let's say we provide the qt is equals to ut. Let's say the step input is our we are going to provide qt is equals to ut. Then what will happen? Then st will come like this. Simple. ut का क्या होगा integration? What is the integration of ut? ut
One.
हाँ rt.
One by.
अरे rt भाई कैसे बातें करते हैं तुम लोग?
Ramp function.
रैम फंक्शन. यस, रैम फंक्शन. ओके. तो ये है आपका प्रॉब्लम. ट्राई टू सॉल्व द न्यूमेरिकल based on this. Okay, so I am just here